Unraveling the mystery of retrograde orbits. Hello, dear viewers. Today, we're embarking on a stellar journey to understand a fascinating concept in astronomy and space science, the retrograde orbit. If you've ever gazed up at the night sky and wondered how celestial bodies move, this video is for you. We're going to break down this complex topic into easy-to-understand pieces, making it accessible for all our English language learners. So, fasten your seatbelts, and let's dive into the cosmic world of retrograde orbits. Before we unravel the secrets of a retrograde orbit, let's understand what an orbit is. An orbit is the path that a celestial body, like a planet or a moon, follows as it revolves around another body in space. Usually, this movement is due to the gravitational pull of the larger body. Most orbits are predictable and follow specific patterns, which is why we can foresee events like eclipses and planetary alignments. Now, let's talk about the most common type of orbit, known as the prograde orbit. In our solar system, planets typically move around the Sun in a specific direction, from west to east. This movement is termed as prograde motion. It's like watching runners on a track all racing in the same direction. This pattern is not just a coincidence. It's a result of how our solar system formed and how the conservation of angular momentum works. So, what exactly is a retrograde orbit? It's essentially the opposite of prograde motion. In a retrograde orbit, a celestial body moves in the opposite direction to the majority of other bodies within the same system. Imagine a runner on the track suddenly deciding to turn around and run in the opposite direction. That's similar to what happens in a retrograde orbit. This type of orbit is rare and intriguing, often sparking the curiosity of astronomers and space enthusiasts alike. Even though retrograde orbits are less common, our solar system does have some fascinating examples. One of the most famous is Venus, which rotates on its axis in a retrograde direction, making its surface movement opposite to its orbital motion around the Sun. Another intriguing example is Triton, one of Neptune's moons, which orbits its planet in a direction opposite to Neptune's rotation. These unique movements challenge our understanding and inspire further exploration and study. You might be wondering, why are retrograde orbits important? Well, studying these unusual paths helps scientists understand the complexities of celestial mechanics and the history of our solar system. Retrograde orbits can provide clues about catastrophic events like collisions or gravitational disturbances that might have occurred in the past. They are like cosmic detectives, helping astronomers piece together the vast, intricate puzzle of our universe. And that, dear viewers, brings us to the end of our cosmic journey today. We hope this video has illuminated the fascinating concept of retrograde orbits and sparked your curiosity about the wonders of our universe. Remember, each time you look up at the stars, there's a whole world of extraordinary movements and patterns unfolding in the vastness of space. Thank you for joining us, and keep exploring, learning, and wondering about the marvels of the cosmos.